Okay. So now we go into DFT. Okay. So we are checking whether the answer what you got using time domain and the answer what you got using frequency domain is same. Okay. For that, what we do, we have convolution. We have this property in frequency transform. When you apply transform, convolution becomes product. So see here what they have done. They have taken FFT of the first signal, FFT of the second signal. Convolution becomes product in frequency domain. So they have multiplied and they have taken IFFT. And this is to check whether whatever the convolution we have done using time domain method, the same answer we are getting using frequency domain or not. You see here, IFFT is taken. The FFT of U, the FFT of the rectangular signal is taken. Okay, and FFT of this second signal is taken and it is multiplied. And it is again taken inverse FFT to see whether the answer is same or not. Yes, see here. This is the answer we got using the inverse FFT method. Okay, inverse FFT method. And this is the answer what we got using normal time domain method. Both the answers are same. This answer is same as, see here, this answer is going to be exactly same. Okay, so we have proved that whether whatever method you do convolution, either in using time domain method or the frequency domain method, the answer is going to be same. Okay, so same way we are given practice problem. So we are the tasks are given. So we are generating two signal. One is sine wave and one is parabolic signal from unit ramp, and we are going to perform the convolution of the two signals. When you know, whenever you want to perform convolution, you have to use the function. You have to use the function CONV. When you use CONV of U comma V, you get the convolution of the two signal. Okay, so we can write CONV of U comma V. This is the sine wave. This is the unit parabolic signal. And this is the convolution. Maybe we'll assign it to some variable W. See if this is working. Yes. The answer, the convolution value is given. Maybe you can see the workspace and get the value for W, what are the coefficients of W. Okay. The same way, you are given task how to find convolution. Okay. So this is going to be the animate function what they have used here to animate the convolution. So this function is available in MATLAB, so you can use that to explore the signal systems better. Okay. So far we have seen one convolution example. We have seen how to perform convolution using analog signal. We have seen how to perform convolution of digital discrete time signal. And we have seen whether different ways of doing convolution, either in time domain or frequency domain, the answer is going to be same. Okay. So next one, we are going to see about convolution in an LTI system.